Okay, the third way of solving systems of equations or finding the point of intersection for two or more lines is through elimination or the addition method. Okay, in example 1, there are two equations of a line. One is x plus y equals 5. The second line is x minus y equals 1. We are looking for the point of intersection, and that's called solving the equations. So in the addition method, what you're going to do is look for a x or y that when you add them up will cancel out. So we're going to add going down, and when we do that we get x plus x, which is 2x, and then the y's cancel out, equals 6. Divide by 2, and x equals 3. But because we're looking for an intersection point, we need the x and y coordinates. So now that we know that x is 3, we need to find out what the y coordinate is of the point of intersection. So we're going to plug the 3 back into either the first equation or the second equation. It actually doesn't really matter which one you plug it into. So for now I'm going to plug it into the top equation. Okay, and then we're going to solve for y. So 3 plus y equals 5. Subtract 3, and you get y equals 2. So the y coordinate is 2. So the point of intersection for these two lines is at 3, 2. Okay, example 2, first line is 2x plus 3y equals 8. Second line is x plus 3y equals 7. It looks like the easiest way to, we could either try to cancel out the x's, or we can try to cancel out the y's. It actually doesn't matter, it'll come out the same. We can cancel out the x's by multiplying the bottom by -2. If we multiply everything on the bottom by -2, the x's will cancel out. So we still have the 2x plus 3y equals 8. And now the second equation is -2x minus 6y equals -14. Oops. Okay, and then we add going down, and what will happen is the x's will cancel out. We have -3y equals, and then 8 minus 14, you can't see the 14, it's kind of off there. 8 minus 14 is -6. Divide by -3. And we get the y coordinate of the point of intersection is 2. Okay, so now we're going to plug it in either to the top equation or the bottom equation. It doesn't actually really matter which one you plug it into. So I guess I can plug it into the top. So we put the 2 in place of the y. So now we have 2x plus 3 times y, which is 2, equals 8. 2x plus 6 equals 8. Subtract 6. 2x equals 2. Divide by 2x equals 1. So the point of intersection for these two lines is at 1, 2. It's also known as the solution. So point of intersection and solution of the system of equations mean the same thing. Example 3, the first line is 3x plus 6y equals -6. The second line is 5x minus 2y equals 14. Because we have a plus 6y and a minus 2y, I think it'll be easier to cancel out the y's, because one's positive, one's negative. We just need to make the y's the same. So if I multiply the bottom equation by 3, that will give me a -6y on the bottom. So now the y's will cancel out. So now we have 3x plus 6y equals -6. And the bottom equation is now 15x minus 6y equals 42. Okay, so we add, going down. The y's now cancel out. One's positive, one's negative. And 3x plus 15x is 18x equals negative 6 plus 42 is 36. Divide by 18. Divide by 18. And you get x equals 2. Okay, and that only gives us part of our point of intersection. We need the y. We only have the x. So you're going to plug it into the top equation, I guess. It doesn't actually really matter which one you plug it into. So we're going to put it in here in place of the x. So now we have 3 times 2 plus 6y equals negative 6. That's 6 plus 6y equals negative 6. Bring that over, that's minus 6. 6y equals negative 12. Divide by 6, and you get y equals negative 2. So the point of intersection, or the solution for the system of equations, is at 2, negative 2. Okay, the last example, first line is 3x plus 5y equals 30, and the second line is 5x plus 8y equals 49. It doesn't actually really matter which one we try to cancel out. We can cancel out the x's or the y's. I'm going to do the x's only because the numbers are smaller. So what I'm going to do is I'm going to multiply the top one by negative 5. No, we'll just multiply it by 5. And that gives me 15x. So the bottom, in order for it to be negative 15x, I have to multiply by negative 3. So this is 5 times 3x, which is 15x. This is negative 3 times 5x, that's negative 15x. So now my x's will cancel out. So we have 15x plus 25y equals 150. And we have negative 15x minus 24y equals negative 27 to 147. Okay, we add going down. The x's cancel out. And we get 25y minus 24y is regular 1y, and 150 minus 147 is 3. So the coordinates for the point of intersection, the y is 3. We need to find out what the x is. So I'm going to go ahead and plug this 3 into the top one. It doesn't actually really matter. You can, oh, whoops, wrong place. We're actually going to plug the 3 into the y, my bad. Okay, so now this is 3x plus 5 times 3 equals 30. That's 3x plus 15 equals 30. Subtract 15. 3x equals 15. And x equals 5. So the point of intersection is at 5, 3.